Today I'm going to teach you about some problem strings. Okay? Problem strings are a way to think about questions where we build from question to question to get you thinking certain ways. Okay? Think back, first of all, please, to the very beginning of school. The very first day of school in my class, we played that game with the cards. You remember that? And I told you we're going to play this game with the cards because it helps us with our numeracy. Do you remember what I defined that word for you to mean? First of all, what does it sound like it means? Something about numbers, right? Numeracy. Our numeracy is how comfortable we are with numbers. Do we have a high numeracy? Do we have a low numeracy? How comfortable are we with numbers? Well, we're going to be adding and subtracting today, and probably even more, but we're not going to use our calculators. Okay? We are going to work on our numeracy. We're going to work on our comfortableness with numbers. Okay? So, let me ask you a question, but I do not want you to answer it out loud. I just want you to think about it for a second. And I'm going to ask it like twice. Wait till I tell you it's time to answer before you answer, please. My question is, what is 99 plus anything? $99 plus anything. This is what I mean. What is 99 plus 47? Well, I may not know 99 plus 47 just right off the top of my head, but I do know 100 plus 47. 147 is 147, right? But I started with 99, not 100, so it should be one less. Okay? So I could think of it as 100 plus 47, which is 147, but minus 1. One less than that. So 146. But I don't want to write that much. So can I think of it a different way? What is 99 plus 63? Can I think in my head 100 plus 63? What is 163? 163 except one less. 162. What about 198 plus 79? Well, 198 is pretty close to 200. In fact, it's 2 less, right? So I'd have to add 2 to get to 200 from 198. Well, if I added 2 here, what am I really doing here? What is 277? 277. For the record, your notebook papers, you could write these down. You need me to scoot it back down for a second? Okay. I need you to develop a familiarness with numbers like this so that we don't always have to jump to the calculator. Okay? In junior high, especially junior high, maybe the lower grades, but especially junior high, you were not allowed to use calculators, were you? Okay? So you had to know all your times tables. You had to be able to add numbers. You had to be able to subtract and divide numbers. Okay? And once you got to high school and we started using calculators, it's like you lost that comfortableness with the numbers. Okay? And a lot of times what happened in junior high was they said, I need you to do this with mental math. Right? Mental math. Well, guys, I'm here to tell you today, mental math doesn't necessarily mean doing it in your brain. It means doing it with your brain. Right? Just because it's mental math doesn't mean I have to do all of it in my head. I just have to use my brain to do it. So am I allowed to jot stuff down if I'm doing mental math? Absolutely. Okay? So what about this problem? 997 plus 48. How would you do this problem? 997 is really close to 1,000. It's 3 away. So if I add 3 here, subtract 3 here, well, I have 1,000 plus 45. What is 1,045? 1,045. Now, do you think it's an accident that I'm asking you the last question the way that I'm asking it? Can you see that when I ask you the question of what is 1,045, isn't the answer 1,045? The question is the answer, isn't it? So if we can get to a point like that, these are going to be a whole lot easier, aren't they? Okay? So last problem in this string, 768 plus 8,999. So, because you saw that 8,999 is very close to 9,000. In fact, 1 away. And if I add 1 here, subtract 1 here, and I get 700. Whoa, wait a second. So you're adding something to the second term? And that's allowed. Why not? But you're saying I want to start with this one and add it to this one. It's the same thing? How do you know that? Because it's addition, and it doesn't matter what order you add in, does it? Is that true for all operations? Which one is it true for? So it doesn't matter what order you add in, and it doesn't matter what order you multiply in? True? True. Does it matter what order you subtract in? Very much so. Does it matter what order you divide in? Also very much so. Okay? So this one would become 767, and this one become 9,000, and then that's just super simple, right? Okay? New string. 99 plus 37. We can do that one in our head pretty quick now, right? 136. But just to make sure, we're adding 1 here and we're subtracting 1 here, correct? Okay. What about 99 plus 69? 168, because added 1 here, subtracted 1 here. Okay. What about this one? 64 plus 129. $129 is really close to 130. So if I add 1 here and subtract 1 here, what I get is 63 plus 130. Are those pretty simple numbers to add together? 193. So if you walked in here at the beginning of class today and I said, what is 49 plus 215? Your first response would have been either I don't know or where's my calculator? Right? Can you do this one now? How would you do this one? So you would add 5 here and subtract 5 here. So you get 44 and 220 to be 264. Did anybody else do it a different way? So you added 1 here and subtracted 1 here to get 50 and 214. Which way was better? Sometimes is there always a better way? No. Sometimes they're just about... Did one take more steps than the other one? No. Okay. Any questions so far? All right, one more problem in this string. 2989 plus 1997. 2,989 plus 1,997. What did you do? You added 1, like to here? You added 1 here and subtracted 1 here. I get 2,990 plus 1996. And then what did you do? Really? Okay. So how right up here we talked about the fact that there's not always a better way, but now we have to talk about that maybe there is a better way. Okay? Guys, I'm not saying this is a wrong way. Okay? I'm saying I don't know if I could still do that in my head. Okay? And if you can, that's so wonderful. All right? I think at least some of you in here probably added 3 and subtracted 3 to get 2,986 and 2,000. Can you see how this would be an easier problem to do than this? 4,986. We're still getting the same answer. Okay? But I'm saying this one might be easier than this one. Did anybody do this one a different way? Did anybody add 11 here and subtract 11 here to get 3,000 and 1,986? Do you see how those are the same though? Okay. Any questions so far? So what about 6.9 plus 2.2? If there's one thing you guys hate worse than big numbers, it's decimals. Okay? What is this number very close to? 7. What does it need to be added to it? We could say 0.1, or we could say a tenth, right? So if I add a tenth here, then I would need to subtract a tenth here, correct? So 6.9 or 6 and 9/10 plus a tenth. 7 plus, what is 2 and 2/10 minus a tenth? 2 and 1/10 or 2.1. Well, that's easy to add. What about this? Seven and 19 hundredths and 2 and 98 hundredths. Oh my gosh, I don't want to talk about that. You know what I do want to talk about? $7.19 and $2.98. Isn't that a lot easier to talk about? Can't I talk about decimals like this that go to the hundredths as money? Guys, you guys are way more familiar with money than you are with decimals. You hate decimals. I know that. I have to help you appreciate them at least, but let's talk about this as if it were money. What does this lack to get to $3? 2 cents. How could we say it like the mathy way? 2 hundredths, right? So if we add 2 cents here and subtract 2 cents here, I get 7, 17, and $3, which equals I think that decimals are easier when they mean something. And I know you've heard me say stuff about like that before. I think equations are easier when they mean something. I think functions are easier when they mean something. If we'll make our decimals mean something, I think they'll be easier for us. And the only thing I can think of that you hate worse than decimals is fractions. Yes? Okay? So let's not think of these as fractions. Let's think of it as money. 5 3/4 is what? $5.75. What's 3/2 in money? $1.50. So if I have $1.50 here and $5.75 here, can I take a quarter from this and add it to the $5.34? If I take a quarter and add a quarter, I get $6 by adding the quarter. How much left do I have if I subtracted the quarter? $1.50 minus a quarter, $1.25. Oh my gosh, I completely stopped using fractions and started using decimals. That is so ridiculous. Is it? Aren't we trying to make it mean something? Doesn't this mean something to me right now? Then I know I have $7.25. And all I really had was some sort of fractional addition problem before. Okay? And if you'll notice, we didn't have to change these to mixed numbers and find a common denominator and carry the 1 or anything like that, did we? We just made them mean something. Okay? Any questions about this? And let's start one more little string here. And this is different because it's subtraction. So, I have some things I want you to think about. So watch this for just a second, please. Because I'm pretty sure you can all do 43 minus 38 in your head. That's why we start with a problem like this. Okay? So what if I had a number line? And I started at 43. And I subtract 38. Well, I can't do that all in my head, but I can subtract 3 to get to 40. Right? How much left do I have to subtract if I already subtracted 3? 35. And if I have to subtract 35 from 40, is that an easy subtraction? Yes. Or, what if I start at 43 and I subtract to get to 38? 43 to 40 is 3. And 40 to 38 is 2. How much did I subtract? Guys, what is 43 minus 38? 5. So I just visually showed you 2 different ways to do this problem, right? But I got to show you one more. When I wrote this up here, did anybody in the room say to themselves, okay, 38 plus something is 43. What's that something? Did any of you change this into an addition problem? How are subtraction and addition, if at all, related? First of all, are they related? Yes, very much so, right? We usually say they're what? Opposites? So if I say 43 minus 38, that should give me 5. But if I say 38 plus something to get 43, shouldn't that also be 5? Okay? So you've got 3 different ways to think of this one subtraction problem. So how would you do this problem? Well, on a number line, we could go from 31 all the way down to 3 by going 1 to 30, and then down 20 to 10, and then down 7. So how many did I subtract? 28. Or I could start at 31 and go down 1 to 30, and then 2 more because I'm trying to subtract a total of, 2 more because I'm trying to subtract a total of 3. That would give me 28. Guess what the answer is? 28. Or I could say 3 plus what number gives me 31. Are any of these ways wrong? Are any of these ways easier for particular problems? If I'm doing this particular problem right here, how many times did I have to make jumps? 3, right? How many jumps did I make here? Just 2, and with much smaller numbers, right? So this one is probably easier for this particular problem, right? But if I'm subtracting a bigger number, it might be easier to do it this way because I'm going like a shorter distance, right? But even this one's not bad because I'm going in big jumps and I only made 2 jumps. You see the difference? Okay. So what about this one? 811 minus 22. If we're thinking about doing this problem the way that we did the addition problems, and I want to get this one to what? What do you think I would get this first number to? 800. So if I'm getting it to 800, I subtract 11, right? What do I do to this side? Because this is a subtraction problem, I also have to subtract 11. Very good. Okay? So this gives me 800 minus 11. Isn't 800 minus 11 a much easier problem than 811 minus 22? And we know the answer is 789. Very good. 253 minus 238. What do you think? How would you do this one? Say again? You want to bring this to 50? How would you bring it to 50? Subtracting 3? If I subtract 3 from here, I have to subtract 3 from here, right? So that gives me 250 minus 235. That's pretty easy to do, right? 15. Now, if you are unprepared to have your mind blown today, then please prepare yourself really quickly. Because watch this. What happens if I add 2? If I add 2 here, what do I have to do over here? Add 2. That makes that 255 minus 240. Oh my gosh, I can do subtraction by adding? 15. Was that your mind exploding? Oh yes, I love that commercial. So you're completely ignoring the hundreds column. Is that allowed? Absolutely, because when you subtract 200 from 200, you're going to get 0, right? So if we do it his way, we would just start with the problem being 53 minus 38. Absolutely. Very good thinking. Okay? Are there any questions about this? So do you kind of see how I'm trying to get you to think on some of this stuff? Yes? Now, how many of you used a calculator on any of those problems? Nobody. Right? Nobody? And if I told you would come in today to my class, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and do 17 problems, addition and subtraction with big numbers, and you would get them all right, you would probably laugh at me and call me a very rude name. But you did. Okay? So now what I would like to do is transition just a little bit into thinking algebraically. And I want you to use this paper because this paper has an area for a table and an area for a graph so that you're not going to get caught up or mess up on the problem in any way because you're trying to create those yourself. Does that make sense? Good. So I want to tell you a story about my friend Ryan. Okay? Do I really have a friend Ryan, by the way? I'm a math teacher, so I don't really have a lot of friends. So usually if I tell you about a friend, they're made up. Okay? So, let me tell you about my friend Ryan. Ryan was walking away from a motion detector at 2 feet per second. Thank you. I don't know where he started. Okay? I didn't see where he started, but I do know that at the 9-foot mark, when he got to 9 feet away from the motion detector, he had been walking for 3 seconds. Okay? So the first thing I want us to do is write down some important information. So I'm going to read it again. And I want you to write down important information that you hear from the problem in this area that says information. Ryan was walking away from the motion detector at 2 feet per second. I don't know where he started. I missed where he started, but I do know that at 9 feet, he had been walking for 3 seconds. Someone please raise their hand and tell me one important piece of information that I heard in this problem. Yes, sir. Okay. I don't know if you noticed, but you just gave me 2 pieces of information. I'm not mad. The first piece of information that he said was that he was walking away. From all our walking with the motion detector, isn't that pretty important piece of information? What does that tell me about the line? It's going to be increasing, right? Now, more specifically, how fast was he walking away? Okay, 2 feet per second. Does that make sense to you how I've written this? Feet per second, feet divided by seconds. Is that okay? All right. And what's the last important piece of information? At 9 feet, he'd walked 3 seconds. How am I going to write that? Do I just write 9 feet at 3 seconds? Or is there a better or faster way for me to write that? Okay. Let's think ahead a little bit and we'll come back to that because I want you to write it the fastest, easiest way possible. Okay? When I go to make my table, what's going to go where? Besides 0 at the top, what's going to go where? Is it? This should be seconds, right? And this should be feet. So my x values in my table are going to be seconds, and my y values in my table are going to be feet. Does that give you any sort of hint about how I should write that information? About the 9 feet and the 3 seconds? That's closer. It's a point, isn't it? It's a point. So what I would like you to do real quick in about 30 seconds or so, maybe 27, is there's 3 things up here on this paper. There's a rule, a table, and a graph. I would like you to fill all 3 of these in, but I want you to start with which one you're the most comfortable with. Start either at the rule, the table, or the graph, but I want you to get them all 3 completed. Would you tell me where you started? Yes. You started with the rule? Okay. What did you use to find your rule? What? The information? Which information? Which part? Okay. Then what did you write as your rule? F of x plus equals 3 plus 2x. So tell me in the information where it says 3. I mean, I know there's a 3 there. Did you use that 3? Okay, you didn't use this 3. So where did that 3 come from? Sometimes I'm going to ask hard questions and you're going to tell me, I just know it. But what I need you to be able to do is let your brain process and tell me how your brain worked. That's not an easy thing to do, guys. I'm not asking you to do something easy. If it was easy, we'd all be doing it. Okay? Can you tell me where it came from? So you can't start at 0 because you're going 2 feet per second. And you know it's going to be an odd number because 2 away from any odd number is going to be another odd number. And then? What did you fill in your table? What does your table say? 03152739. Is this 3 in the table somewhere? Where? How do you know that that is that particular 3? Because when time was 0, I was 3 feet away. Or Ryan was 3 feet away. Right? So our rule then, what is this number again? Our starting point? And what's this? What number is this? Our rate. So our rule is our starting point plus our rate times our seconds, right? Okay. So what's your graph look like? Oh, so you put your labels on first? Very, very good thinking. We can't graph anything unless we know what's where, right? Okay. So you counted by ones. And on the y-axis? We will finish this tomorrow. Have a good day.